This is fun. Hi, I'm Steffen. Do you remember the basic training? We used this toy excavator to analyze the motion of specific points. But did you also know that you can use 3D data from scans or CAD models to analyze areas where no points are visible? Typical applications include collision analysis. That involves measuring distances and contact points of moving objects, something not possible when only using points. Furthermore, this method enhances the visualization of the motion of parts and objects in a 3D view. Now you can see the motion of the objects themselves and not just the points. This is often crucial in a documentation of the results. Additionally, this approach also works with quasi-static load tests, which have been measured with the tri-top photogrammetry system. Now let me show you how all this works. Okay, now you can see here the movement of the excavator with already tagged measures in the presentation mode. I will leave that presentation mode and I will go to the testing inspection workspace. So again, you can see here the movement of the excavator. But when I switch on the inspection of the bucket itself, there is no mesh yet. You can just see the movement as an inspection of the point component, and you can see just the vector arrows. To get a better visualization, I need to import a mesh. Therefore, I'm grabbing the mesh file. Can be an STL or G3D file, for example. Just a file out of a 3D scanner. I import this file as a clipboard. And as you can see here, inside the clipboard there is a new mesh. It is colored gray and the location is a little bit different. So we need to align the mesh to the component bucket. But first of all, I want to change the color because it's gray, and as a small tip, you can set the color as you like. Just go to the properties of the mesh, go to display, surface, front side, and I will change it to black in the same way as a toy excavator. Second tip, if you don't have a 3D scanner, you can also convert a CAD body to a mesh. Very easy. Go to Operations, go to CAD, go to CAD to Actual Mesh. This is also possible. Okay, now I want to align the bucket to the point component bucket. Therefore, I will open up the picture-in-picture. I will set the mesh exclusively here in the picture-in-picture, and I will go to Operations, go to Alignment, go to Single Element Transformation, and this is quite important. You need to use the Single Element Transformation because you want to transform a single element inside the 3D view. And now I'm going to 3-point alignment. Okay, I will do it again here. Now I'm using an image overlay because it's much better visible. I align it in the same way in the picture-in-picture and in the image. Switch off the displacement here, and now I need to align 3 points of the mesh to 3 points to the point component. Now it's quite important that you select the mesh bucket, and now my nominal points are points of the component and not the component on the mesh, because the new nominal position is the position of the point component. Three points here on the bucket and 3 points on my point component. Okay, I think looks quite nice. But the bucket is not moving, therefore we need to tag the mesh to the point component. Also very easy, go to Operations, go to Elements, go to Tag Element to Component. Select the bucket and tag it to the component bucket. Now it is moving exactly with the point component. Therefore, it's quite important that there is no deformation of the point component, because the mesh is also not deforming, and this is quite important. Okay, what can I do with that? So we already evaluated the point as a vector field, but now I can evaluate the mesh. So for example, you can see the tooth in the background. I can create, I construct a point, construct point, point. For example, to this position, create and close, and I can evaluate this point, for example, for displacement. This is the displacement of the tooth of the bucket and not of the point component itself, and this is quite nice. Furthermore, additional functionality, I can measure the distance of the bucket to the ground, for example. And this is quite important, for example, for collision analysis. Also very easy. I will select the bucket in the Explorer and I will select all points of this element. Looks red here. And I will go to Inspection, Deviation to Geometry, and I project the values to the ground. And now you can see a colored mesh which shows the deviation, the distance from the knots of the mesh to the ground here. And this is quite important, as I mentioned before, for example, for collision analysis. In summary, we can easily utilize measures from 3D scans or CAD models. Therefore, we just align and tag them to the point component. This helps for a better visualization of the motion sequences. Additionally, it's also possible to evaluate areas that were not previously measured. As we have seen, we can evaluate distances and represent them directly on the mesh. This is particularly important when analyzing the collision of parts. Please note, the point component must be rigid. Deformations are not allowed. The mesh must be well aligned with the point component. I hope you enjoyed this introduction to the extended motion analysis. And for more hacks and tutorials, check out our YouTube channel, like and subscribe. See you next time.